Good morning. Let us study today what are called radial wave functions. What are their features, the important features of radial wave functions, their significance, how to plot the radial wave function, graphical representation of radial wave functions, what are called nodes. Let us see today. Now let us see what are called radial wave functions. The total wave function is obtained by solving the Schrödinger wave equation of hydrogen or hydrogen-like atom. Okay, we have seen in hydrogen-like atom, hydrogen atom problem, by solving the Schrödinger wave equation of hydrogen or hydrogen-like atom, the solutions obtained are called wave functions. The wave functions are nothing but atomic orbitals. Each wave function corresponds to a particular orbital, atomic orbital. Therefore, the total wave function is equal to product of radial wave function and angular wave function, where r equal to radial wave function that depends only on distance, radial distance r, whereas the product of theta, capital theta and capital phi is called spherical harmonics. We have already studied in hydrogen atom problem. The product of theta and phi is called angular wave function. Okay, how the wave function is obtained by solving the radial wave function or angular wave functions are obtained by solving the Schrödinger wave equation. The radial wave function or describe the dependence of the total wave function on the radial distance r. Okay, whereas the angular wave function give us the shape of the atomic orbitals. Angular wave function actually represent or gives the shapes of the atomic orbitals. The radial wave functions obtained for the first three orbitals, are as given below. For 1s orbital, the radial wave function is given as r1s equal to k1s exponential minus zr by a0. For 2s orbital, the radial wave function is represented as r2s equal to where k1s, k2s, k2p are normalization constant for 1s orbital, 2s orbital and 3s orbital respectively. k1s, k2s, k2p are called constants. Okay, and these are all exponential, decay exponential functions, where Z equal to nuclear charge for multi-electron atom. For hydrogen atom, Z equal to 1, m is the mass of the electron, h Planck's constant, a0, where a0 is the first Bohr radius. This is constant. The first Bohr radius is constant, that is 0.529 Armstrong unit. For many electron atoms, we have already studied the exact solutions, the exact wave functions are not readily obtained or impossible to obtain. Only by approximation methods for multi-electron atoms, the wave functions are obtained. So, the hydrogen atom wave functions are generally used as a first approximation for polyelectron atoms. In the case of polyelectron atoms, the use of hydrogen atom wave functions where we neglect the electron-electron repulsion. Still, it is the hydrogen atom wave functions are used as a first approximation for polyelectron atoms. So the wave functions are obtained by solving the hydrogen-like atom Schrödinger wave equation. The graphical representation and the graphical representation of the radial wave functions. See, the way radial wave functions are mathematical equations. We have seen in the previous slide, the radial wave functions are mathematical functions or mathematical equations. Therefore, they can be plotted. The graphical representation and the significant features of the curves. Significant features of the curves are given below. The graphical representations of 1s orbital, 2s orbital, 2p, 3p, 3d orbitals are shown here. The radial wave function is nothing but a mathematical function or mathematical equation. Therefore, it can be plotted. The radial wave function plot for 1s orbital is shown here. Actually, y equal to y, r1s is y, and r is, small r is radial distance x. In x-axis, it is taken in x-axis. The plotting of 2s orbital, the radial wave function plot for 2s orbital is shown here. As you see here, the decay, the decay is faster. The exponential decay is faster. Here, for 2s orbital, the exponential decay is slower, and again for 3s orbital, the decay is much slower. Okay, and the important feature, what are the important features observed in these curves? For 2s orbital, there is one node, that is r2s equal to 0 at this distance r, at this radial distance r. Okay, r2s equal to 0. In 3s orbital, there are two nodes. There are two nodes here, that is r3 at this distance, radial distance, r3s equal to 0. This is 0. At this distance, this is 0. So, in general, for 1s orbital, 0 node. For s orbitals, n minus 1 nodes were observed. Okay. For example, 2s orbital, 2 minus 1 node. For 1s orbital, 1 minus 1, 0 node. There is no node. There is 0 node for 1s orbital, because this is asymptotic curve. It won't meet the x-axis. It won't meet the curve, won't meet the x-axis. This is the graphical representation of 2p orbital. This is the graphical representation of 3p orbital, where for 3p orbital there is one node. At this radial distance, r3p equal to 0. For 3d orbital, there is no node, because this is not meeting the x-axis. Okay. In general, for p orbitals, there are n minus 2 nodes. For 2p orbitals, 2 minus 2. For 3p orbital, 1 node. Similarly, for d orbitals, there are n minus 3 nodes. From the radial wave function plots, what are the important features obtained? What are the important features of radial wave function plot? 1. They all represent an exponential decay. See, in general, they are all represented by an exponential decay, e power minus zr by n a naught. The exponential decay is similar to radioactive decay. For n equal to 2, the decay is slower. I have shown. See, the decay is faster for 1s orbital, and for n equal to 2, the decay is slower, and this is for n equal to 3, the decay is much slower than for n equal to 2. Okay. For this reason only, the radius of the orbital increases with the n values. For example, n equal to 1, this is the radius, small radius, n equal to 2 and n equal to 3. So the radius of the atomic orbital increases with the increasing n values. There is another important feature is there is one node for 2s orbital. There is no node for 1s orbital. There is one node for 2s orbital at r equal to 2a0 by z. Therefore, at this radial distance, 2a0, let us substitute here 2a0 by z. Therefore, 2 minus 2 you will get. 2 minus 2 means 0. 0 into 0, 0. Therefore, R2s equal to 0. Okay. At this radial distance, this is often asked in GATE CSIR examination. Okay. For 3s orbital, there are two nodes. For 3s orbital, there are two nodes. Therefore, in general, for s orbitals, there are n minus 1 nodes. For p orbitals, there are n minus 2 nodes. For d orbitals, there are n minus 3 nodes. Thank you for watching. Let us study in the next class radial probability wave functions. What are called radial wave probability wave function? Thank you for watching.